Now let's look at how tar can help us. Tar allows us to aggregate content from one or more directories recursively. This is a feature that can come in quite handy when you need to back up a number of directories. Recursion is the key. So in extending our compression utilities, we also include tar. Now oftentimes when you find content online, it's usually tar followed by some compression format such as gzip or bzip version 2. The idea behind tar is that it creates archives. So this is an archive creator. Creates archives of one or more files or directories. So what's common or custom in the Nix space is to use tar to aggregate one or more files or directories and then compress using a tool such as gzip or bzip version 2. That's what's customary. So let's see how we'd actually put this to use in the world of Nix. So we've got directories that we'd like to back up, and we're going to put tar to work. So tar. Now tar supports a number of options. The common option for creating an archive is C. We normally turn on verbosity with the F option. Now we specify the name of the file, the output file first, followed by one or more paths. So file name .tar followed by one or more paths. Paths can include files and or directories, one or more. So let's take a look at our example. In our directory we've got a number of files. Messages as well as test. Ideally we should have a directory structure to represent in our archive, but we can back up a flat directory such as the current directory. So for example, let's create our first archive, tar cvf. We'll call this messages.tar, and the path will be messages star or messages.star. This will include in the archive the three messages files. Now let's take a look at the messages file .tar, and there's the archive. It's 21,504 bytes. It should reflect the sum of the various messages files because it doesn't provide compression, but it rolls them into an archive. This is a flat directory of this particular set of files, messages.x or messages.bz2, gz, and zip. Now what's so important or what's so interesting about this? Nothing when you're backing up one flat directory with a handful of files. But as you start to spread information across the file system, the Unix file system, then tar becomes quite useful. And then used in conjunction with one or more compression utilities such as gzip or bzip version 2, it becomes even more useful. So as an example, let's just update this to reflect what we've done. Messages.star. And in this case, we've called it simply messages.tar. So creates archive of three messages files sans compression. We have not referenced a compression option. However, the three files that are included in the archive are originally compressed and they'll remain compressed within that archive. So of course this begs the question, how do we extract files from an archive? So before we get into archiving directories one or more, let's just quickly extract what we've created to a different directory. So perhaps we'll make a directory temp and then change into it, and then tar instead of cvf to create an archive will xvf to extract an archive, followed by the name of the file, which is simply one level up messages.tar. So let's copy this string. The first thing it'll do is make a directory from the current directory, which is the user's home directory, which pwd tells us. We currently do not have a temp directory, so make directory temp will make the directory. Then, if successful, the shell will change into the directory, and if that is successful, tar will extract one level up, because at that point we'll be one level down in temp, the messages.tar file into the temp directory. And if that is successful, we'll LSL. Now this will happen quickly. And there we see the three files reconstructed in the temp directory. So the archive has been restored to its original form, which is 3 compressed files. So that's how you extract a tar archive that has not been compressed using one of the supported algorithms, bzip2, gzip. Now, insofar as directories are concerned, now we'd like to back up a number of directories. So tar, cvf, instead of a flat file or set of files from the existing directory, we'll back up a number of directories. So let's call this UCBT.miss.tar to indicate that it represents a variety of directories from the user's home directory. Although you're not necessarily relegated to directories that are relative to the user's home directory, you could specify directories anywhere within the Unix file system, so long as you have access to read and descend into those directories, so read-execute privileges on those directories. So UCBT.miss.tar is simply a visual indicator to us that the tar archive will contain items that pertain to the user UCBT. So what's of interest? Well, let's include the temp subdirectory. But let's not stop there. Let's see what else may be of interest. We'll go one level up. So temp will be included in the archive. And perhaps we'll also include the 10 million .text items. So let's go ahead. In fact, let's create some additional directories. We'll make a directory temp2, temp3, and then place some items in them. So let's move 10 million star into temp2, and if that's successful, we'll then move test star into temp3. That'll give us content in those directories. Let's echo the exit status. And when we echo the exit status, in this case, it's of the last command that was run, which was move test star into temp3, not of the previously executed commands, because in order for the final command to run, the previous had to have run, and the previous would have had to have run. So there's a chain in effect that's honored. So now when we take a look at the temp subdirectories using lsl temp star, you'll see that temp contains messages, temp2 contains 10 million, and temp3 contains test related files. So this gives us content to back up. So we'll back up temp, temp2, and temp3 into our archive. And this is where tar becomes quite useful, because we can then specify disparate directories and files from our current directory, all rolled up into a tarball. So it creates a single archive out of 3 directories. And this is why when you download source code from online, it's often represented in tar format, because there are many directories for the project of interest. Anything, for example, Sugar CRM. You may download the tar.gz file, and it contains a myriad directories enclosed within. Tarballs represent those myriad directories in one file. And then when you've extracted that one file, it reconstructs or recreates the entire directory hierarchy. So let's go ahead and do this. Again, this is all sans compression. So it creates a single archive out of 3 directories, sans compression. Compression comes in another point when we invoke the appropriate compression option for the algorithm that is desirable. So this will create the archive file in the current directory unless we indicate that it is to be created somewhere else. Our current directory is the user's home directory, reflected in the prompt, with the tilde symbol. So let's go ahead and create this, and now we should see the UCBT.miss.tar file, which, as we can see, is 10.525.184, so about 10 megabytes, a little bit over. Again, the only items that are compressed within this archive file are the ones that were previously compressed, these files. So that's why it's a full 10 megabytes. So now we have a tar archive. Now how do we interact with this archive? Well, we can extract it. We can list the contents within the archive. Let's say we've forgotten, a number of days or months or weeks have passed. We can tar tvf the name of the archive, and that extracts a dump to standard out, not of the actual archive in real time, or not the real archive extracted, but rather just the metadata associated with the archive. So it dumps it to screen so we know what's contained. Notice that the directories are pointed out as such with a leading D in the first bit to indicate to us that there are 3 directories and the rest are files. So in temp3, for example, you have these 4 files, or in temp2 you've got these 3 files and these 3 files in temp. So that's what's contained within the archive. So that's how you create and extract. To extract, you simply tar xvf. You go to a directory that's of interest and you tar xvf. You can extract anywhere. If you extract in the directory in which you archive the original directories, you'll cause tar to extract over the original directory. So it's often advised to extract to a new location. So for example, we'll make a directory temp, in this case 4, navigate into temp 4, and then tar xvf UCBT miss.tar. That recreates the entire structure in this directory, temp, temp3, temp2. One command that can quickly navigate or descend through the directories recursively is du. Du with the human readable format returns that the full thing is 10 megs. You drop the S and it shows you the directories that are contained within. You may also elect to create or recreate directories specifically. So for example, let's remove rf to the subdirectories of this particular directory, temp4. You can extract individual items from an archive using tar, which is also quite useful. Because sometimes, for example, let's say a tar image contains a number of directories for various platforms, of which you're interested in only a specific platform, or perhaps a number of directories of which you're only interested in a few. Then you can specify those few using tar. So for example, tar xvf UCBT, you have to specify the name of the file, miss.tar, and from the perspective of the temp4 directory, it's going to be one level up .. Now supposing we'd like to recreate solely the temp2 structure, that's how you'd indicate it. So you specify exactly what is to be extracted from the tar archive. So this regenerates or untars only the temp2 directory hierarchy recursively from the UCBT.miss.tar file. So that's one way to do it. Let's extract. In fact, we will just find in our history and specify explicitly the temp2. Now you may be wondering, you've forgotten what's in the tar archive. Again, tvf. So tar tvf UCBT tab completion with the bash shell makes it easier, and this tells you what's in the archive. Let's just note that because you will definitely not know all of the items contained within. So tar tvf, the name of the archive, enumerates contents of archive in the event that you don't recall. So then to tar xvf, the items that are of interest, let's say we'd like to have the temp2 hierarchy recursively recreated. Let's echo the exit status. Now notice instead of leading A's, we see leading X's. A means archived, X means extracted. So the X tells us that it's been extracted. And there is the temp2 hierarchy. A DU with the CH option will enumerate the contents and their sizes, and it's been extracted fully for us. An LSL of temp2 will reveal the items within. So you can specify. Now what if you wanted 2 directories? Let's remove RF temp2. Let's say you wanted temp and temp3. That's quite possible as well. So now we have temp and temp3. And if you'd like the entire archive, then don't specify individual items contained within the tar archive. So that's the way you'd get around that. Now we don't need this temp4 directory, so let's navigate a level up, remove RF temp4. And that cleans that up to save us a little bit of space. So enumerates the contents, and you can specify the directories that are of interest. As an option, let's just indicate that we have tar xvf from the archive, miss tar temp, as well as temp3. And this untars solely temp and temp3 directories. So that's how you extract. Now, we've yet to incorporate the capabilities of compression. So certainly, it helps if we can roll a tarball and compress it at the same time. So before we've used bzip2 as well as zip and gzip to create our various compressed files. How do we use that in conjunction with tar while preserving the entire hierarchy? Well, again, the beauty of tar is that it preserves the hierarchy, the directory hierarchy, so it recurses. That's the beauty. gzip also does it. bzip2 currently doesn't. So it helps if you use them both in conjunction. So, as an optional means, now we'd like to use it with compression. To use it, let's say with gzip compression, we turn on the Z option. So to create an archive, we use C. To enable gzip, we use Z. And then the other options, VF, remain. And the rest is all the same. The name of the file that we'd like to create, let's say UCBT miss.tar, we'll just remove the one that's there, followed by one or more directories. So let's take this string. We'll back up the same directories. And let's affix what you may more commonly see online, which is tar.gz or tgz. Either or will work. It simply visually indicates to us that the file is a tarball archive as well as a zipped file or gzipped file. So archives and gzips, which means it compresses. Let's go ahead and include this in our dump. And again, we'll remove the current version of UCBT miss momentarily. In fact, to compare and contrast, let's move UCBT miss to UCBT miss.tar.old. That way we can compare the file sizes. And then we'll create the new archive. So we have leading A's for each of the rows to indicate that an archive has been created. And let's compare and contrast. We'll turn on the human readable option for the UCBT files that are there. So one is 28K. Again, orders of magnitude improvement. Again, from 10 megs to 1 meg is 1. A meg to 100K is 2. 100K to 10K is 3. So we're somewhere between 2 and 3 orders of magnitude realization improvement. So this is tar.gz. Now, how do we tell the differences between these two files? Well, file against UCBT miss.tar star will give us a sense. Miss.tar.gz is a gzip compressed data file, and miss.tar.old is simply a POSIX tar archive, which means it's not compressed. Now, it contains compressed items, but overall, all of the items are not compressed. How do we enumerate the contents of this newly created tar archive? Well, just as we've done before with the T option. So tar tv f, in this case it's UCBT miss.tar.gz, and it shows us what's contained within. We need not turn on the extraction option for the compression type, in this case gzip. And how do we enable this with bzip? Well, instead of Z we use J. So tar, same string but J. Let's just copy this entire block and replace Z with J. J is the hook to indicate bzip version 2. Then we also change the suffix from GZ to BZ2, which is customary, or even bzip, but BZ2 is common. And archives and bzip2s, if you will, because it's bzip version 2 compression. So let's try this out to see what footprint improvements we've realized. Now let's echo the exit status, and we'll again LSL UCBT star, and let's take a look at the difference as well. Again, it's a realization of, in this case, almost 10,000 bytes from 28K to 18K. So the bzip version 2 file is even smaller. Its footprint is much nicer, much lighter. And again, if you think about what's contained within, there are files that include our DD dumps of 10 million texts, which doesn't contain numbers, but rather 10 million bytes. But the point is, it's been significantly reduced, orders of magnitude reduced, which is what's important when using these sorts of utilities. And you can extract at will. Now, what about including in your archive items from all over the file system? That's certainly something of interest. For example, let's say your task is to ensure that certain log files are backed up from time to time, as well as items from your current directory. So you may use your system on a regular basis as a username Unix CBT, but your responsibility extends beyond that. You need to get some log files in there and so on. So first and foremost, you take a look at what you have access to. So in var log, that's where the log files are kept. You look for items for which everyone has read access, or the group to which you belong has read access. Now, if you don't belong to the wheel group, which is not the default for a non-privileged user, then you need to check the last 3 bits, which corresponds to everyone else. So in this directory, we see that everyone can read the messages file, and that's the general system log file. We cannot read mail as well as security. And what else may be of interest to us? Xorg. So those 2 so far seem to be of interest. Also, last log may be of interest. So let's include those in our mix, for example. So we'll tar, and since we know bzip version 2 gives us superior compression, JVF, and we'll call this daily backup logs.tar.bz2. And we'll point to var log. In this case, we want xorg.0.log and var log messages and var log last log. These are 3 files that we have access to. So these will be included in a flat directory. So creates archive, and rather creates compressed archive of 3 log files. Now let's go ahead and copy this in. And by the way, tar also allows you to add and remove, so to manipulate the tarball over time so you can move along with it and reflect the current changes on your system. So this will be our daily backup file, and it contains those 3 items. Let's first echo the exit status, and if clean, then tar tvf daily backup logs tar bz2. So those are your 3 items. Now this tells us if you extract any of these items, the entire hierarchy will be recreated. Let's show you what we mean. Let's make a directory temp4, change into temp4, and then tar x jvf. X is to extract, J indicates bzip version 2 is the compression algorithm that's of interest. 1 level up, daily backup logs tar bz2. And you'll see momentarily that it recreates the full hierarchy, which is var, log, and then the various items within. And you can specify individual items. Let's remove the entire var tree. So now you've decided you want solely the messages file. Well, let's see where messages exists. It doesn't find messages flat from the archive. What about the full path? Var log messages, and that it has found. So let's see. It's recreated var, log, and solely messages, nothing else. Tab completion helps confirm that. So you can extract individual items so long as you reference the path contained within the tar archive to get to that particular item. And of course, compression is realized. So let's navigate a level up, followed by remove RF of temp4, followed by an LSLH of daily star. So it's 11K. How does this compare? Well, if you tar tvf daily, you'll see the sizes of the contained items. 104,807, 44, so 148, almost 150,000 reduced to 11K. So again, an order of magnitude plus realization on the compression side. So you can include items from outside of your home directory. You can mix and match if you'd like. For example, we have items in our current directory that are of interest. Let's say the log file should be included plus our various temp directories. Then you just mix and match. So J, let's just include this entire string. And also note tilde temp star wildcard. And let's bring this up, paste it over to the shell. And notice it's picked up on temp, temp2, temp3 because of the wildcard. So now let's ls the daily backup, and it is 31,828. Let's tar tvf daily, and these are the items within. And again, if you run tar help, you'll see the myriad options. Again, you can maintain your tar file for an indefinite period, making changes as you go along, adding, subtracting, excluding items, and so on. It's quite flexible. You can also restore permissions that were originally on the files of interest. So again, the idea is that tar does this recursion for us in and outside of our default directory spaces. As we've mentioned, gzip supports this as well. So let's do a gzip help. Here's a recursive option. So if you were to, let's say, gzip create, and we want, let's say, the temp directory to be included in the archive, sending it to, let's say, temp.gz. Now notice it throws temp as a directory because we didn't turn on the recursion option, and now it works. So now, when we gzip and we list the contents of temp.gz, we'll see it includes a temp directory, which includes items. And if we extract it, let's make a directory temp4, change into it, gunzip, temp.gz. This will dump it here, and notice it shows that it already exists, and because it already exists, it throws an error, but it aims to recreate the entire hierarchy, which is what tar would have done. There's limited support in gzip, absent support in bzip2, so that is why you'll often find archives that are tarred as well as compressed using one of the formats, usually bzip2 and or gzip, whenever you're looking for content online. This is why we use the two of them together. And so far as the extensions are concerned, let's navigate one level up, remove temp4. Let's look for things that contain tar or star tar. So we've created this archive tar.gz, tar.bz2. Sometimes you'll see tbz, which includes that it's tarred and bzipped, or tgz. The suffixes are not important. For example, file star tar star will check those files. So for tar bzip2, it knows it's bzip2 compressed. For regular tar, it's just POSIX tar, and so on. You can change the suffix. So for example, move daily backup logs to daily and use tab completion to make it quicker. And simply change this, let's say, to tbz, which you might find online. And then when you rerun the file against it, it still shows up, the tbz file that is, as in this case, it doesn't show up in the list. Let's do a file on star tbz. It still shows up as bzip compress and can still be extracted accordingly. So same thing for gzip. You just name it tgz or something else that you see online. The key is that the file is represented as an archive and is compressed with a format that is familiar to you. That's all that really matters when you're using tar. Now, in order to variabilize, let's say, a daily backup, you'd have to call, let's say, one of the shell features using command substitution. Let's just throw in one other thing that we mentioned in the shell scripting space. So we've created a daily backup of log files, fictitious daily backup. However, it might be of more interest to us to variabilize this. So the system keeps running date. Date is one of those commands that tells you the current date. And you can use date formats such as date plus %f to give you a format like this, which I like. Or you can explicitly indicate what you want, the parts like y, %m, for example, %d. This is another format that I like to use. So you can create files, generate files like these using command substitution with the bash shell, as well as other shells like corn shell, etc. This will variabilize the target file that you create so that you can run it in a simple script. So instead of simply daily.backup.logs.tar.bz2, you may want to include backticks or $ open and close parentheses to variabilize the output file. So now you'll have this one-liner create a unique file for every day. And the more you vary the date, the more variable the output file becomes. So let's just see what happens in this particular case. As long as today is the current date, it'll generate a file with that particular name. And now let's echo the exit status, and we should see lsltr. It has created a file with the prefix 2011-09-16, so on and so forth. And every time you run this, it'll just generate the same file so long as the day hasn't changed. And it'll overwrite that file. And of course, you can further variabilize it, perhaps including the second. So for example, with the date command, if you do date help, you'll see the various variables that allow you to put some more useful information in there. %s, for example. And this goes through the seconds to generate files that are unique with second resolution, or even more unique than that. But usually daily is good enough. So this will create, so creates variable output file based on day. And it's a one-liner that you can include in cron or in a simple shell script with a shebang header that will ensure that you have a generic file, or a unique file that is matched to the day. Not a generic file, but a unique file that's matched to the day that contains information for that particular day. So that's a way to variabilize things. And this can work, of course, with any of the commands that we've run. The alternate way to run backticks is, as we've mentioned, to use $ with parentheses. So for example, Control-A to go to the beginning of the line, and instead of backticks, we can use $, open parentheses, and then run the command that's of interest. Remove the closing backticks and close with the parentheses. This performs the same function. So let's lsltr, and we should see it somewhere towards the end here. And there's the same file. So an alternate way to run this, let's just take this entire block because it does the same thing, but it's just another way that the shell interprets command substitution. And that is to substitute backticks, because sometimes it can be a little tricky in your scripts, in particular with other languages such as, let's say, Perl. You have to do more escaping. So this might be a more manageable, tractable form for you. So create variable output file based on day using $ parentheses command substitution. Whereas this one here uses backtick command substitution. So using backtick, and these are just backticks, command substitution. So those are two optional ways of doing things. So again, you can roll your archives using tar and compress using bzip version 2 or gzip, and then transmit your information across the web. The only thing is, if you're dealing with users who are using Windows, they'll need programs like WinRAR or otherwise to read the tar archive. RAR is just such a format which allows us to recursively back up structures and compress as well. So RAR is yet another tool that's available. And let's just see if it's built in. And currently isn't, but we can find it. So RAR, UnRAR are also available, which will make you compatible with Windows-based systems. So that's a little bit about how tar works in conjunction with gzip as well as bzip version 2, the two most commonly packaged formats you'll find online for code in the world of open source Unix and Linux.